Hello world and welcome to this edition of Tech on Fire with Blaze. I'm Blaze Stewart, an architect at Winelect, and today we're going to be looking at an overview of Azure Infrastructure as a Service. Hi guys, today we're going to be launching a new series on Azure IaaS, where we're going to be talking in depth about various components of Azure Infrastructure as a Service. Now today we're not going to get into the details of all this, but I do want to give you an overview of what Azure IaaS is and what it encompasses. So we're going to be doing a high-level overview of all the components of Azure IaaS and walking through the various categories which we can stick these into on Azure so you can get an idea of how all this stuff works together. In an earlier video we talked about the differences between infrastructure as a service, platform as a service, and software as a service. And today we're not going to be getting into the differences of these things, but really focusing on infrastructure as a service. And then within the context of infrastructure as a service, we mentioned four things. We mentioned virtualization, servers, networking, and storage. Now, we're not going to be talking about virtualization really per se in infrastructure as a service, because that's really the platform which these other three fall into. We're going to be talking about servers, which we can also call compute, storage, which is where data is stored, and then networking, which connects all these things together. And then the components that Azure has in these three categories is really what defines infrastructure as a service on Azure. Within the context of Azure Infrastructure as a Service, there is compute, networking, and storage, as we've already mentioned. And then within the context of compute, there is virtual machines. Now, virtual machines are really the elephant in the living room when we talk about infrastructure as a service on Azure. And the reason why is so much stuff is connected to those virtual machines. It's where all the compute is really done. It's where a lot of the storage is connected to. It's where a lot of the networking interfaces are connected to. So Azure Infrastructure as a Service really kind of centers around the idea of a virtual machine. So the virtual machine itself, though, consists of a lot of different things too. It can range in the number of cores it has, the amount of RAM it has, and these cores and RAM really determine the kind of the use cases for it. So you have very small VMs that might have a single core and a minimal amount of RAM, to humongous VMs that have lots of cores and a lot of RAM dedicated to those various machines. And they're designed for different kinds of workloads, from very small websites to high performance computing scenarios and such as that. Also within the context of these virtual machines are a wide array of operating systems. So you have Linux and Windows are kind of the two big players, but you can also have things like network appliances that can be installed as a virtual machine on Azure, and that can be used as an interface to the outside world or even between various subnets within the context of Azure. So if you're very comfortable with say something like an F5 appliance, you can use a virtual machine appliance on Azure with F5's software installed on that virtual machine. So you can see that within the context of an infrastructure as a service and virtual machines, you have a lot of variability even with that context. So these things are highly configurable and there's a lot you can do with them. Now, Azure as Infrastructure as a Service has two basic options for handling high availability within the context of compute. The first one is an availability set. Now, an availability set is essentially just a way to define clusters of virtual machines that allows Azure to move these things around whenever it's doing updates in the background on Azure, or in the event of maybe some internal issues that are going on inside of an Azure data center. So these availability sets and update zones give you the ability to create clustered technology, but you are responsible for managing those clusters and those VMs and defining what goes into those VMs. So this is just one option that's available. The other one is a VM scale set. Now, VM scale set is a little different from an availability set, because really what it's doing is taking a image of a VM and then replicating that across multiple VMs. So a scale set will allow you to scale horizontally very quickly with VMs. So you can define an image, and then I want to have 3 in my base set, and then between the hours of noon and 6 o'clock in the evening, I want to add 2 more nodes to that scale set, and so I can handle my traffic. You can also define rules such as CPU uses or network utilization, or you can do it even manually if you want to go in there and just for a while add 10 more nodes to your scale set. You can do that very easily. And so you're essentially just creating a bunch of clones of a given image within that scale set. So availability sets and scale sets give you the ability to create high availability scenarios on Azure infrastructures, and then the VMs themselves are really kind of the thing that does all the work for you within the context of that compute scenario, whatever it might be. The next thing we want to talk about on Azure Infrastructure as a Service is storage. Now, storage is related to virtual machines, but not inextricably linked to it, because there's multiple kinds of storage on Azure Infrastructure as a Service. The first one is file storage. Now, file storage is the ability to have the file service on Azure that you can use as a mount point or a map drive on a virtual machine in Azure. So this will allow you to store data off the virtual machine on some other storage technology that's in Azure's data center, but it's not running on a virtual machine. So you don't have to have a virtual machine in order to have a storage server. And this also gives you the ability to share data among virtual machines, because you can have that file service on multiple virtual machines as well. And you can also use it to, in some cases, mount back onto an on-premise storage solution and have the ability to write things to Azure from a local machine that's not running on Azure. So the ability to use file services is one of those infrastructure pieces that gives you a lot of flexibility. It also comes in multiple tiers for various performance options depending on your needs. The second kind of storage that's available on Azure is storage queues. Now, storage queues work something like a service bus or something like that. Now, what these do is they give you the ability to write to a queue on Azure, and then you have an application that can be triggered by that queue that's essentially listening for new things to be added to that queue. So these messages can be written to that queue and then be popped from that queue by way of an event, and then that event then can have some kind of functionality that's based on the message that's written to that queue. So it's kind of a low-cost option for doing queuing technologies within the context of storage that's not using like a service bus that uses more high throughput technologies like MQTT, but this is a more low-tech option, but it does work in much the same way. Or the third kind of storage on Azure that I want to mention is blob storage. Now, blob storage is unique from file storage because blob storage is a API level storage on Azure that allows you to write just pretty much any kind of data to it. It's not going to tell you what kind of data you can and cannot write to it. But blob storage is essentially a non-file system way of storing data on Azure. Now, blob storage itself can be used for all kinds of things. It can be used for running websites, for instance. It can be used for hosting videos. It can be used for hosting images. It can be used for backups. It can be used for all kinds of things. The options for blob storage are really unlimited in terms of the possibilities, what you can use it for. But unlike file storage, blob storage doesn't have the ability to mount that into a virtual machine. Really, it's accessed by way of an SDK or through a REST API. But in any case, it's very much a part of the infrastructure story on Azure because a lot of services use it in the background for storing data on the Microsoft Cloud. Then there's table storage. Table storage is a lightweight table that allows you to store data into essentially rows and columns, and it gives you the ability to query that data at some level. So you can do some OData queries against it, and the OData queries allow you to set filters on it as well. And it also provides some pretty robust partitioning, data partitioning. So with this table storage, you can write some things that are like database applications against it, but in and of itself, it's not a full-blown database. It's really more for writing things that aren't really highly relational or something that you don't really need to do a lot of querying against. But in any case, it does give you the ability to do some lightweight querying against that data. And it also doesn't have to be structured data. You can write the schemas to this, and the schema isn't locked into a data table schema like you would have in a traditional database. It's rather flexible, so you can ad hoc add new columns or remove columns from whatever it is that you're adding to table storage and other things like that. So it's really up to the user to define it. So with table storage and storage queues and blob storage, you have a lot of infrastructure as a service options on Azure for doing a lot of different kind of unique cloud-centric applications, and then file storage being an option that gives you the ability to do more traditional type file sharing and copying of data from more traditional type applications that are running in virtual machines. The last thing I want to mention are disks on Azure. Now, disks on Azure are the things that you would actually mount into virtual machines, and these are mounted as logical volumes on a virtual machine, and then you can partition those up into drives or other partitions on the virtual machine itself, or you can build RAIDs on them or anything like that. They essentially work the same way a hard disk does on an actual physical computer. So these disks work with virtual machines, and they can have different tiers available on those disks as well. So you can have high performance disks, you can have local storage, or you can have what might be considered, it's not remote, but it's not on the same physical hardware as the CPU and RAM. That kind of storage has higher latency. So there's a lot of variable options on disks as well in the context of how you can use these disks. And some of them are what we call unmanaged disks, which is a more legacy technology in Azure. Then you have managed disks, which show up as resources on Azure inside of the portal, and as well an Azure Resource Manager that allow you to mount disks into virtual machines, and they are treated like first-class citizens as well in the Azure ecosystem. So between these 5 options, you have a lot of available options for storage. Now, there are other storage options on Azure that get more specific into certain use cases, but these are probably the 5 most general purpose ones, and that's why they would be included in Azure Infrastructure as a Service. The platform as a service will have things like database as a service, will have things related to HPC and things like Hadoop and other things like that you can look into for platform as a service. But for the purposes of infrastructure as a service, these are kind of the 5 options available on Azure storage that are in the context of infrastructure as a service. Last but certainly not least on Azure Infrastructure as a Service is networking. And I want to go through this as quickly as I can and do it justice, because there's a lot of services that I want to mention here. First are the obvious things, virtual networks. Now, virtual networks are the thing that connects all of the virtual machines on your Azure subscription together. Now, the ability to control this is done by a myriad of things that are baked into that virtual networks. You have the ability to set up various routes, subnets, and you can control things like that within the context of the VNet that are defined either through the Azure portal, or you can do it by declarative means, which will through ARM templates, which we can talk about at a later date. Now, the ability to control traffic that flows in and out of your virtual network is done by way of network security groups. Now, a network security group is essentially a layer 3 or layer 4 firewall that gives you the ability to filter out things based on the ports that are available to that virtual network, or through various CIDR blocks that might be defined on those rules that are in the network security group. Now, we did a whole video on how these counter firewalls work. Check it out in the link below, and you can watch a video on how routing works and how firewalls work, and how these network security groups work in the context of a virtual network on Azure. Now, there are 2 ways of controlling traffic on Azure that are kind of built into the infrastructure. And the first one of these is a network load balancer. Now, a load balancer is exactly what it sounds like. It balances loads between virtual machines on Azure. So with a load balancer, you can define what ports you want to listen to, or what IPs you want to listen into, and then farm that out to a set of static VMs that are running independent of one another through a availability set, or even to a scale set. And it has the ability to be internal and externally facing as well. So you'll have a public IP that's assigned to that load balancer, and then it will farm it out to various internal IPs that are available to your scale sets or your availability sets or VMs. Another one that's particular to layer 7 or particularly HTTP traffic would be an application gateway. Now, an application gateway is a layer 7 device that looks at the HTTP traffic that's flowing into a given network, and it has the ability to do things like network SSL termination, so you can use it to host your SSL certificates. It also can do URL-based routes into various virtual machines on Azure if you have those different routes defined for a given endpoint. You can say send app1 to VM1 and then app2 to VM2 by way of URLs that are defined inside of your application gateway. And it can also do things like a web application firewall that are baked into the application gateway as well. Now, related to these are other technologies that you can use to connect your virtual networks back to on-premise systems or to remote systems through VPNs. Now, a VPN is exactly as it sounds, a virtual private network. A virtual private network, it gives you the ability to have a tunnel across the public internet that then will connect to your back-end systems on Azure and provide a private tunnel between one system that's remote and Azure itself. So the VPN gateway on Azure is just one way of doing that. Another way to do that is through express routes. Now, express routes are a lower level way of connecting on-premise systems to the Azure cloud. It does it by agreements that Azure has with telecoms. And the telecoms then will provide a low-level connection, possibly a layer 2 connection in the OSI model to your on-premise data center, and then connect that up to Azure, and then expose that to your virtual network on Azure. And then you will have something that's more or less an extension of your data center in the cloud. And this is a hybrid scenario for building out infrastructure as a service on Azure that will complement whatever it is that you're running on premise. Now, related to these technologies are some external infrastructure as a service offerings from Azure that I do want to mention here. The first one is Azure DNS. Now, Azure DNS gives you the ability to manage your domain name services with Azure, and you can register your domain names and then park it on Azure DNS services, and then use that to manage your records. So it essentially will do all your lookups on your domain name services against Azure instead of using a third-party one such as GoDaddy or one of the many other ones out there. Then there is a service called Traffic Manager. Now, Traffic Manager is external to your network as well, but what Traffic Manager does is integrates with something like a DNS service, and what it does is it acts as a way of farming out traffic to various regions in Azure based on rules that you define in Traffic Manager. So it can be used for things like failover scenarios, or it can be used for load balancing scenarios, or it can be used to direct traffic based on geographic availability or closest data center or things like that. So it's really using DNS to do that. So whenever someone goes to my domain, say winelect.com, and I want to get them to the closest instance of my website, I can use Traffic Manager as a way to do that. And another way to do that is through content delivery networks. Now, content delivery network is a way of sending traffic across the internet and then storing assets in remoter locations and copying. These are static assets that get copied to Azure data centers around the globe, and then they are geographically located closer to a end user. So in theory, these assets would be delivered faster to that end user. And some common scenarios for this would be things like videos, images and static things like JavaScript files and HTML files, and you store those on the CDN, and then that CDN just provides a endpoint that is much closer to the end user, and that end user then can load your website faster. In most scenarios, that does work. So these 9 various options on Azure act as infrastructure as a service on Azure to provide a very robust suite of network-related options under the umbrella of Azure infrastructure as a service. If you like this content, please consider visiting us online at www.wintellect.com, and there you can find about services that Wintellect offers, including training and consulting services. Also, please consider subscribing to this channel by clicking on the subscribe button and clicking the bell icon to get notifications when new content becomes available, and also comment down below. You can also follow me on Twitter at @TheOneMule, and also follow Wintellect on Twitter at WintellectNow or at Wintellect. We are constantly posting things about Azure-related technologies and things related to software development. You can also reach us by email at consulting@wintellect.com. Until next time, thank you.